In this video, we're going to look at graphs and try to back out what the linear equation is for a given graph. So remember, when we look at the graph, we can identify a couple of key features that will help us determine what our linear equation is. And all we need to solve for are our y-intercept. Remember, this is when x equals 0, then y is equal to b. So that's the first thing that we're going to identify. Then we're going to determine the slope. And remember, the slope is just the rise over run, or a delta y over delta x. Now, we're going to remember that the sign of the delta y and delta x components are very important. And so we're going to take that into consideration when we are determining what the rise and run terms are. So let's take a look at 5 different example problems to identify what the linear equation y equals mx plus b are. All right, here's our first graph. So remember, we're trying to identify the equation y equals mx plus b. So the first thing we do is try to identify what the y-intercept is. And all this is when the line intersects the vertical axis. So I can see that the line intersects the axis at the origin or at the 0 location. So immediately I can see that the y value of the at the intersection is equal to 0. So b is equal to 0. All right, and that's a good starting point. So I can start here and walk along the lines. Now with a grid lines like I have here, it's easy to identify, it's convenient to identify when you hit some of these corners. So I don't know how well you're able to see this, but you have these corners that represent specific values that the way I've set up this grid easily allows us to identify what the value of the point is along that line. So from this point, if I rise 1 and I go to the left 1, I hit a point right there. So that's my slope is equal to rise 1, so delta y over delta x. All right, rise over run. Going up 1 is a positive 1. Going to the left, that's going to the negative direction. In the x direction, that's negative 1. Rise 1 to the left 1, right? So this is negative 1. So this equation is y equals, has a slope of negative 1 and a y-intercept of 0. So negative 1x plus 0, or I can just say y is equal to negative x. Okay, let's take a look at our second problem. Here's our second problem. We're going to do the exact same thing. Y equals mx plus b. So identify what b is first. So we look at the vertical axis and see where it intersects the line. And that's occurring right there at negative 4. So b is equal to negative 4. All right. And then we're going to start at b. And we can see that this is a positive slope because you're walking up the hill in this direction. So we'll go up and to the right. And so you see that this line crosses a grid point right there. So I can go up 1, 2, and then to the right, 1, 2, 3. So rise is plus 2. Run is to the right, plus 3. So my slope is 2/3. My y-intercept is negative 4. So my linear equation is 2/3 x plus, 2/3 x minus 4. Right? The slope term here and the y-intercept b term here. Okay, let's take a look at another example problem. right? And, just looking at this, do you think this is going to be a positive or a negative slope? So keep that in the back of your mind. Let's take a look first at what is the y-intercept. So it looks like we're crossing the y-axis at +3. So that's my y-intercept. And then let's take a look at my slope. Well, we're looking like we're going downhill as we move in the positive x direction. So I know that I'm going to have a negative slope, or expect a negative slope. So I can either say, let's march downhill, 1, 2, 3. So that's a -3 for delta y. And I'm going to have to move to the right, so it's a positive delta x, 1. So +1. You could alternatively go up 3, 1, 2, 3. So a +3 for the numerator, and to the left, so -1 for the denominator, and you get the same value. So the slope here we see is -3. So we got our slope, we got our y-intercept. Now I can write my linear equation, y equals m, which is -3x plus b, 3. Okay, let's take a look at one more example problem. Well, actually, we have two more example problems. Here's another one, and we're going to go through the exact same process. So first, we identify what the y-intercept is. If you're able to see it, go ahead and write it. That's right there where it intersects. So +4. And we'll start right there. And we'll march up 1. That's +1 for delta y. And then we'll go 1, 2, 3 to the right. So +3. So this is +1/3 for the slope. So my linear equation is y equals 1/3 x plus 4. And then our final graph we have here, we're going to go through the exact same process. Try pausing this video and see if you can get the same equation that I do. Okay, so step 1 is we look at the y-intercept. In this case, it looks like a cross at -6. And then we look at our slope now. So I can go, let's see, let's march up. I'll go 1, 2, 3, 4. So +4 because it's going up. And now to go to the left, so it'll be a negative value, 1, 2. So this gives me -2. I'm just looking at here. I could have gone here. I could have gone up 2, 1, 2, and then to the left 1. So I could have done +2 for delta y and -1 for delta x. You see that you get the same value for the slope regardless of what you choose. So this equation gives me y equals -2x minus 6. So hopefully you get a sense of how you look at a linear equation. First identify the y-intercept, and then from the y-intercept, or from the y-intercept point, march towards another point that you know the value of, and then you can determine delta y and delta x from it. Pay attention to the signs, so make sure that your the sign of your slope is consistent with the shape of the linear equation.